Now we're going to look at some odd powers of x. We've already looked at the even powers. Let's see if there's any pattern to the odd powers. We're going to sketch graphs of f of x equals x cubed and x to the fifth power. We've already graphed x cubed earlier in our course, so I just recopied the table of values that we used, and I'm going to go ahead and plot the points again just to remind you of the shape of the graph. -3, -27, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8, 3, 27. So we've already seen this x cubed function graph. And we can note the end behavior, right? The end behavior when as x approaches infinity is the same as the end behavior for even powers of x. So f of x approaches infinity. But the end behavior as x approaches minus infinity is not the same as even powers of x, because as x approaches minus infinity, the y values become very, very negative without bound. And so we say f of x approaches minus infinity. So as x gets very, very negative, the y values of points on the graph also get very, very negative. Now let's go ahead and look at a graph of another odd power of x, x to the fifth, and just compare to x. We're going to compare to x cubed afterward. And so I computed some of these fifth powers ahead of time here. I'll start at the bottom again. 3 to the fifth is 243. 2 to the fifth, you should be able to do in your head, is 32. 1 to the fifth is 1. 0 to the fifth is 0. -1 to the fifth is -1. -2 to the fifth. So the thing about these odd powers of negatives is we get negative results, right? This will be -32. And -3 to the fifth is going to be -243. And sort of like the even powers, when I get to larger exponents, I have to change the scale on my graph. I can leave the x scale the same, but now to fit these points, I'm gonna do this. I'm gonna go 100, 200, 300, and similarly in a negative. And now let's go ahead and plot -3, -243 is right about there, because that's 250 at the blue line. And -243, sorry. -243 is down here. Okay, got that fixed. And -2, -32. So that's -50, -32 is about there. Of course, -1, -1 would barely show up below the x-axis. 0, 0, 1, 1. Then 2, 32. And 3, 243. So I get a very similar kind of shape to the shape I got for x cubed. But with x to the fifth, it's a little bit more flattened out. It's a little steeper as x approaches infinity and x approaches minus infinity. Let's get rid of my boo-boo here. There we go. And the end behavior is the same as the end behavior for x cubed, right? As x approaches infinity, f of x approaches infinity. As x approaches minus infinity, f of x approaches minus infinity. And so pretty much all odd powers of x are going to follow this same pattern. And there's one comment I want to make just before we move on is whatever happened to x to the first power? We kind of leave it out of this discussion because its graph is not curvy. In fact, when we write f of x equals x to the first, that's the same as the graph of, you can think of it in mx plus b form as 1 times x plus 0, right? So it's a line, it's got a graph that's a line of slope 1 and y-intercept 0. It's just the same as the line y equals x. And so because it doesn't have a curvy shape, we just tend to leave it out of this discussion. Although the end behavior is the same, symmetry is kind of similar, but it's so simple we don't include it in this discussion of power functions. We've intentionally left it out. All right, so I think I'm going to stop this video, and in the next video we're going to summarize what we know about these even and odd powers of x.